Sophisticated SoCs these days have lots of cores, and they typically need a network to connect them all together. So, Andy, we're going to be talking about tiling. What's the difference between soft and hard tiling when we're designing a system?
Yeah, hi. Absolutely. Tiling is really divided today into sort of two main camps. One is, if you can think about tiles as being hard tiles, perhaps existing as chiplets, where we have a physical link that basically connects two different chiplets together serially on the same die, and you can replicate out mini chiplets and actually make as many connections as possible on that die. So that's one concept, if you like, of tiling. Another concept of tiling is where you actually have a soft tile. So that's a replication of a piece of logic that exists in a design tool. And you're able to actually take that piece of logic, define it, and actually repeat it multiple times in a modular fashion and replicate that out inside the design. And then the tool renders out that configuration, and that then becomes, the resultant RTL. So those are the two definitions that we're going to be talking about here today.
So, how does software tiling differ from just using a network on chip or NoC?
So really, when we're talking about NoC tiling, we're actually talking about the ability to take portions of the network interconnect, for example, the NIUs, so the network interface units. So they're some of the most complex logic in a network on chip. When you have multiple of these, and we're talking in an 8x8 mesh configuration, 64, for example, processing elements, each connecting to that mesh with a network interface unit. That's a lot of manual configuration. So what we've now done is we've actually enabled the designer to define this once, because it's a multiple repeating unit of the same processing accelerator.
Mhm.
And the NIU parameters are actually put in there, and the tool is able to replicate out that on behalf of the designer and adjust all the individual configurations so that where that is instanced in the particular position in the mesh, all of the parameters that need to be changed pertinent to its position, such as its ID in the network, for example, that's all done under the hood automatically for the designer. So all they need to focus on is, what does that logic block do in that accelerator element of the mesh? How does the network interface unit get configured? What's its width, and what's its protocol, for example? And how many of them the designer actually wants, and the tool takes care of the rest of that for them.
Now, Arteris actually has a tool that's going to be addressing this. Is this a new tool or an improvement on what you already have?
Oh, absolutely. It's a new functionality in an existing tool. And this is because it's built upon many iterations of very proven technology. So that the backbone in our case for AI applications is a mesh network. So we have a very much a silicon proven technology in that sense. But what we're doing now is we're actually building on top of that technology to add this tiling, this soft tiling functionality on top of that, to actually give extended advantages for the designer, such as scaling up the network easily just by defining one unit and multiplying out, um, taking advantage of the voltage and power saving facilities in the network. So that bolts into each tile, and each tile can then be manipulated in terms of, for example, frequency scaling in blocks or domains within the design. And also, once a design has actually been set, a derivative design might be constructed from that. And all of those tiles that are pre-configured in the previous design can be lifted and integrated wholesale and actually reused very, very easily.
So, how might this look in the tool itself?
Yeah, absolutely. So on the left-hand side of the diagram here, what we see is your chip layout diagram, a stylized view in this case, and we have an NPU, a neural processing unit, and that consists of a whole bunch of processing elements. And all of these are individually ID'd, but all of them actually have the same logic inside them. If we look on the right-hand side, we actually see in the design environment, we actually have this replicated out. We have one tile that's configured in the top left, and the designer actually tells the tool, I want 64 of these in the design in total, and the tool itself takes care of all of the other instances and configures those automatically for the designer. And as you can see, it's very well represented visually in a layout view, in terms of what we've got on the left versus what actually appears on the right. And it's very close to the actual visualization there for the designer to work with, and to, of course, configure and manipulate.
Well, we've been talking about this more from high-end view. What are some of the applications where this is actually going to be used in?
Yeah, absolutely. So what we have here is a typical use case application that we see coming up many times from our customer perspective. So looking specifically at the automotive segment, for example, this use case example shows how the NoC tiling supports machine vision with object detection. So multiple AI accelerators, including image processing modules, feature extractors, neural network accelerators, are all employed in the vision pipeline. So NoC mesh topology provides the most effective communication infrastructure for these processing elements, allowing seamless data exchange and collaboration amongst the accelerators. So this is an ideal candidate for building a neural processing unit as part of that vision pipeline, and also an ideal candidate because each of these elements is identical. The parallel processing in this, is basically all of these elements working on portions of the data at the same time, and all of these elements actually being effectively identical logic. So that really lends itself well to the tiling technology of creating one of these identical elements and modularly telling the tool, when you create the NPU, create me 63 others. And I mean, 63 is just in this example. I mean, we've not really got an architectural limit in our tooling at the moment. We put an arbitrary limit on for now of 1,000 tiles, for example, 1,000 of these processing elements, if you like, in the design at once, just by configuration option.
Thank you very much, Andy, for filling us in on the latest from Arteris and how soft NoC tiling works.